Hello all, let's start part 2 of section 1.2. As I promised that I'll do another video on section 1.2, and our main focus in this video lecture will be rational equations. A little bit complicated forms of rational equations. Of course, in part 1 of this video, I covered the simple one. I covered rational equations like this. For example, 2 over x minus 3 plus 3 over x minus 3 equals 6. Here, denominators were the same. It's really easy to solve this equation. What you do, you just take one of the denominators and you multiply to every single term involving in your equation. But what if someone gives you such a problem, for example, 3 over x plus 5 minus 2 over x minus 3 equals 1 over x squared plus 7x plus 10. In this case, what will be the common denominator and how to find the common denominator? Then it's easy to solve the equation. Before I start talking about solving these type of rational equations, let me review a little bit with you some types of factoring that you may need to solve a rational equation. For example, in this example that I read for you, you see x squared plus 7x plus 10. You have to first factor this if it's possible. If it's not possible, of course, you keep it that way. But if it's possible, you have to first factor it to know what are the factors of this trinomial. Then after that, it's easy to find the LCM or the least common denominator in this problem. For example, here, immediately I know, oh, the factors are x plus 5 and x plus 2. Correct? But how I found these factors, it was the topic of discussion in beginner algebra. Also, factoring is the topic of discussion in intermediate algebra. But as I know, as I read your discussion, your check-in, most of you, you don't have before an intermediate algebra class, or even if you had, it was a long time ago. Let me quickly review some important types of factoring here for you. Not all of them, of course, at least some of them, correct? Then the first topic of discussion will be factoring. The first type of factoring, we call it the GCF factoring. For example, if someone gives me 3x squared plus 9x cubed minus 12x, and they're asking you to factor this trinomial, how would you factor this trinomial, or which way you are starting to factor this trinomial, given trinomial? The first type is GCF. Every time, every single time, remember this, write it as a note. Every single time that you want to factor a given polynomial, it doesn't matter, it's trinomial, it's binomial, or it's a polynomial. In general, I call it polynomial. That means how many terms you have. First, try the GCF. See if something is common between the terms. We call that one GCF. From the school, you know the GCF between 3, 9, and 12 is the lowest number that all these three can be divided by. Even if you don't remember what is that number, do it like this. Again, the process is similar like what I taught you yesterday about LCM, a little bit different. Start with the number that all of them can be divided by, not one of them, all of them. That's the difference between finding LCM and GCF. The only number that all of them can be divided by is 3. 1 time, 3 times, 4 times. If you see there is another number that all of them can be divided by, continue. But if you see there is not such a number that all given 3 numbers can be divided by, stop here. The number on the left side is your GCF. Write it down here, 3. Now, how to find the GCF between x squared, x cubed, and x? Make a note. When you're looking to find a GCF between variables with exponent, always choose the variable with the lowest exponent. Here you see x squared, x cubed, and x. My GCF will be x to the power of 1 or x. Like this. That is your common factor. Now, open a parenthesis. What you do, what you should write inside the parentheses, actually you do this. You divide all terms by your GCF. All terms divide by GCF. 3x squared divided by 3x gives you x. Plus 9 divided by 3 gives you 3. X cubed divided by x gives you x squared. 12 divided by 3 gives you 4. And x cancels out with x. Here you go. Easily, you could factor a polynomial by GCF. One more example, then I'll explain the next step because we don't have time. This is not the topic of discussion of college algebra. I do a little bit extra for you, correct? Let's look to this example. 2x squared y squared plus 8x cubed y minus, let's say, 6x to the power of 4, y to the power of 5. Easy way again. First, GCF between 2, 8, and 6. Definitely, I know it by heart. The GCF is 2. Between x squared, x cubed, and x to the power of 4, the lowest exponent, which is x squared. Between y squared, y, and y to the power of 5, definitely y. That's my GCF. Now open a parenthesis, divide each term by your GCF and write the answer inside your parentheses. 2x squared y squared divided by 2x squared y gives you only y. 8 divided by 2 gives you 4. X cubed divided by x squared gives you x, and y cancels out with y. minus 6 divided by 2 gives you 3. X to the power of 4 divided by x squared gives you x squared. Y to the power of 5 divided by y gives you y to the power of 4. And you are done. Correct? One more. 3x squared plus 9x plus 27. First, between the numbers. Between 3, 9, and 27, definitely 3. Between x squared, x, and you don't have x in the last term. Remember, if the variable is not involved in all terms, you cannot take it as a common, correct? You cannot find the GCF because last term doesn't have a variable, correct? Then the only GCF will be 3. Divide all terms by 3 and write inside the parentheses. That will be your factor of this polynomial. Type 2, the famous one that we use it a lot, we call it the difference of squares. If someone gives you a difference of squares, a squared minus b squared, or in some books even they're using this, x squared minus a squared, whatever notation you use. You see, it's the difference between two squares, correct? How to factor? Immediately open two parentheses. Which one? I want to do both of them. It's really easy. Take the square root of the first term. What is the square root of a squared? Of course, a. Write in both parentheses. Or even in this example, what is the square root of x squared? It's x and x. What is the square root of b squared? It's b and b. What is the square root of a squared? Here, if you go in this format, a and a. Choose one of the signs and one of the parentheses positive and the other one negative. You are done. You factor. We call this factoring the difference of the squares. Numeric example, 9x squared minus 16. They're asking you to factor. Remember, difference of the squares. The terms involved, usually you have two terms. It's a binomial. You cannot have three terms in this type of factoring. It's two terms. It's a binomial. And each term should be a perfect square. You see, 9x squared, both of them has a square root. 16 has a square root. Then it's easy to factor. Open two parentheses. The square root of 9 is 3. The square root of x squared is x. 3x and 3x. The square root of 16 is 4 and 4. One of them positive, one of them negative, you are done. This is the easiest factoring, which we call it the difference of the squares. Remember, difference of the squares. If this sign was positive, I could not factor. It should be difference, correct? If it's positive, you cannot factor. The third type, which is also a little bit they explained for you in a green box on page 114 of your book. I will go over it. There are actually two types of them. Factoring trinomials. Trinomials means they have three terms in it. Some special type of them, not all of them, correct? How you factor. Let's start with the easy one. If your trinomial is in the form of x squared plus bx plus, let's call it c, correct? Numeric example, x squared plus 9x. For example, let's put all of them positive, plus 20. How to factor this trinomial? General form is in the top. I put a numeric example below that, correct? I'll give you 4 scenarios or 4 cases that you will deal here with this type of factoring, correct? Case number 1. In case number 1, your B is a positive number and also your C is a positive number. In case 2, B can be a positive number, C can be a negative number. Case 3, B can be negative number, C can be a positive number. And case 4, both of them can be negative. You are dealing with 4 cases or 4 scenarios to can factor a trinomial. Now, how to factor? In this type of factoring, always look to 2 numbers or find 2 numbers that if you multiply them gives you C, and if you add them or combine them, even not adding, because sometimes you subtract, if you combine them, it should gives you B. Correct? How to find that number? Always look for the possible factors of C. If I explain it in general form, you will not understand. Here, my C is 20. For example, I'll do this example for you. X squared plus 9x plus 20. How to factor this? What are those numbers? I will not spend hours thinking, what are those numbers? Which number times which number gives me 20? Which number times plus that number should give me at the same time 9? Of course, this example, it's a very easy number here, 20 and 9. Maybe you know it very fast, but if the numbers are big, you cannot think. Then how to find? Write all possible factors of 20. 20 times 1 gives you 20. 2 times 10 gives you 20. 4 times 5 gives you 20. These are the possible factors of 20, right? These are the possible factors of 20. Then, now look, which pair, if you multiply, gives you 20? Of course, all of them, when you multiply, gives you 20. When you add, which pair gives you 9? Definitely this one, 5 and 4. Then what you do, immediately open 2 parentheses here, put the square root of first term, here x and x always. Now, how to choose the sign? I told you that I'll give you 4 cases. Case number 1, when B is positive, C is positive, always choose both number positive. The numbers that you are choosing, both of them should be positive. It means put positive to both parentheses. One of them 4, one of them 5. Here you go, you factored it. This is the quickest method that you can factor a trinomial. Let me write another example for you. X squared, let's say plus 5x minus 14. In this case, case 2, you see your B is positive, but your C is negative. How to choose the numbers, I will explain first here, then I'll start factoring this example for you. How to choose the numbers? Very easy. If your B is positive, C is negative, choose the numbers different sign, but how? Your bigger number should be positive, your smaller number should be what? Negative. Now, look for the possible factors of 14. Possible factors of 14 will be positive 14 times negative 1, negative 2 times what? 7. These are the possible factors. You cannot factor 14 anymore, correct? Which pair to add gives you 5? Definitely this one, right? Then open parentheses, 2 parentheses, x and x, 1 parenthesis negative, one of them positive. Correct? Your bigger number was 7, positive 7 and negative 2. Here you go, you factor. Case 3. Let's say x squared minus 6x plus 9. And case 3, your B is negative, your C is positive. Again, choose two numbers, N and M. Both of them, in this case, should be negative. Correct? How to find the numbers? Factor 9. Negative 9 times negative 1 gives you positive 9. And negative 3 times negative 3 gives you positive 9. Which pair gives you negative 6? Definitely this one. Then open 2 parentheses, x and x, negative 3 and negative 3. Case 4. Which one is case 4? X squared minus 7x minus 14. And case 4, B is negative, C is negative. Choose two numbers again, M and N. One of them negative, one of them positive. But this time your negative number should be bigger. How to find those numbers? Factors of 14. Negative 14 times 1 gives you 14. 2 times negative 7 gives you 14. Actually, I have to change this number. Sorry, I have to change this number. Not 14, 18. I was wrong, making a problem immediately in my mind. I have to choose the number. 14 cannot give you that. 18. Negative 18 times 1. Negative 9 times 2. Negative 6 times 3. And that's it. These are the factors, possible factors. Which pair gives you negative 7? Of course, negative 9 and 2. Then 2 parentheses, x and x, correct? X minus 9 and x plus 2. We call this one factoring trinomials. I know in a school, do you use this method for you? I'm not focusing on that method, but I'm not telling you to follow my method. Which method you know it, which method you understand, and you do a mistake, you don't do a mistake, use that method, correct? But in your book, and college level, we usually go this way, correct? These are the important types of factoring. There is one more type, which is similar to this, and we call it a x squared plus bx plus c. Here, the coefficient of x squared is not 1. In the type that I explained to you, always the coefficient of x squared is 1. But here, the coefficient of x squared is not 1, it's a number. It's written in your book on page 114. For this method, how to choose the numbers, still these 4 cases are applied. We are using the same 4 cases for them. It can have 4 cases, but how to choose the numbers, there's not much time to explain that one also for you. Just read page 114, the green box. You will see how to factor those. Okay, now back to our normal lecture, which is solving rational equations, but a little bit complicated forms, correct? Before solving, if I give you few fractions like this, x here in the denominator, here x squared in the denominator, and here, for example, x minus 3 in the denominator. What will be the LCM or LCD between these denominators? Or how to choose the LCM, or how to build the LCM between the denominators? First, between these two, between x and x squared, it's really easy. The highest exponent is your LCM. Between x and x squared, definitely I'll take x squared as a LCM. Because between 2 and 4, the LCM is 4. You go for the bigger number, correct? Not GCF, LCM. Then between x and x squared will be x to the power of 4. But here you see x minus 3, but you don't have it here, you don't have it in this denominator, then definitely x squared times x minus 3 as your LCD or LCM. This is how you find always common denominator between algebraic expressions, correct? If you have algebraic expressions in your denominator. One more before solving. X minus 3, here x plus 4. What will be the LCM? You see, nothing is common between them. It's like if you have, in a normal, if I show you as a numbers for you, 2 in the denominator, 3 in the denominator, and 5 in the denominator. There is, and the LCM is to multiply these numbers because all of them are prime, right? You cannot factor them anymore. If your denominators are like this, prime, it's really easy to choose the LCM. The LCM is the product between the denominators, but always keep it as a factor form. X times x minus 3 times x plus 4 will be your LCM. Do not multiply, please. Keep it in factor form. Correct? This is how you are taking common denominator if your denominators are different. Now, I'll solve an example from your book. I'll solve a rational equation for you, correct? For example, example number 6 of your book, page 114, 3 over x plus 6 plus 1 over x minus 2 equals 4 over x squared plus 4x minus 12. X squared plus 4x minus 12. How to solve this equation? Easy. Where to start? If you see one of your denominators can be factor, first factor, please. Correct? You see here, maybe I can factor this. I will try. 3 over x plus 6 plus 1 over x minus 2 equals 4 over. It's a trinomial, right? You open two parentheses, x and x. What are the factors of 12? What are those numbers? To multiply gives you negative 12. To add gives you positive 4. Of course, x plus 6 and x minus what? 2. Now it's the time to find the LCM. Let's find the LCM between denominators. I have x plus 6 here, and I have x plus 6 here. I'll take one of them. I have x minus 2 here, and I have x minus 2 here. I'll take one of them, not both. Then this is my LCM. Now, how to solve the equation? Multiply your LCM to all these three fractions. It means do this. Three over x plus 6. Let me rewrite the problem here first. Plus 1 over x minus 2 equals 4 over x plus 6 times x minus 2. Now what I do, I'll take my LCM and I will multiply it to each fraction. I will multiply the first fraction with x plus 6 times x minus 2. I will multiply the second fraction with x plus 6 and x minus 2. And I will multiply the other side, the third fraction, also with the same LCM, x plus 6 times x minus 2. Now, again, I'm repeating. After you did this, I'm telling you multiply, but please do not distribute the 3. First, start canceling. The idea, the reason behind multiplying the LCM to these fractions is to cancel the denominator, to simplify this equation, correct? Here you see x plus 6 cancels out with x plus 6. Here x minus 2 cancels out with x minus 2. Here x plus 6 cancels out with x plus 6. X minus 2 cancels out with x minus 2. Now rewrite your equation with leftover. What left here in the first term? 3 times x minus 2. Plus what left in the second term? 1 times x plus 6. Even I shouldn't write this one, but because it's the first example, I will write for you. Equals what left on the other side? Only 4. You see the denominator is gone. Now it's a simple linear equation, and you know, I explained to you how to solve it. Distribute 3 to both. It gives you 3x minus 6 plus x plus 6 equals 4. Combine like terms on the left side. Positive 6, negative 6 cancels out. 3x plus x gives you 4x equals 4. Divide both sides by 4. Then x equals what? X equal 1 will be final solution. But now, is this the solution for this equation? Because if you remember from last night, or last lecture, part 1 of this lecture, you have to plug in this number in your denominators. The first denominator was x plus 6. The second denominator was x minus 2. And on the other side, you had x plus 6 times x minus 2. If I plug in one here, one here, one here, one here, which one becomes zero? None of them, right? None of them will become zero. It gives you a number. Then you can say, oh, this is my answer. If one of them changes to zero, then it's not your answer. Your answer will be no solution. I talked a lot. I made the lecture longer because my plan was to explain a little bit factoring for you and also these types of equations. I'll stop the lecture here. In future, we will come again. I'm sure you will deal with rational functions. We will explain it again and again there. I'll stop the lecture here. We are done with 1.2 and see you all in section 1.3.